Now let's look into more detail into ionic compounds. Ionic compounds are always made of ions. Not only are they made of ions, but they have to contain cations, which are positively charged, and anions, which are negatively charged. The positive and the negative must cancel one another out to give a total charge of 0. So as a reminder, cations are positively charged, anions are negatively charged. Now we have already looked at this, but we want to remember that metals are always cations. They are always positively charged if they are in a compound. Nonmetals don't have to have a charge in a compound. For example, they could be a molecule. However, if a nonmetal is in an ionic compound, then it's going to be an anion. And most polyatomic ions are usually anions. So let's take another look at the periodic table. Metals are going to be positively charged, and alkali metals always have a charge of +1. Alkaline earth always have a charge of +2. Aluminum, 1, 2, 3 columns over, is +3. Zinc is +2. Silver is +1. So we have a little diagonal, 3, 2, 1. If we look at the nonmetal side, halogens are -1 because they're 1 column away from the noble gases. The oxygen family, -2. They're 2 columns away from the noble gases. Nitrogen, -3, and 3 columns away from the noble gases. And I said earlier that carbon and silicon typically don't form anions, and that's true. But your book is going to introduce you to the handful of compounds where carbon and silicon have a charge of -4. So it's extremely rare, but it is possible. In ionic compounds, the charges are key in figuring out what the formula is going to be. And the formula is going to be the smallest whole number ratio of cation to anion. As I said earlier, the sum of the positive charges, due to the cations, must equal the sum of the negative charges, due to the anions. So let's look at an example. Sodium is +1. Here it is, an alkali metal in the first column. In a compound, it will always have a charge of +1. Sulfur, called sulfide when it's an ion, has a charge of -2. And if we look at the periodic table, here's sulfur in the oxygen family, 2 columns away from the noble gas, so yes, it has a charge of -2. So the charges don't cancel out. +1 and -2 don't equal 0. So what we're going to be doing is figuring out the ratio so we can have more than one sodium ion that's necessary so that the charges cancel out. Since sodium is a +1 charge, we're going to need 2 sodium ions for every S2- or sulfide ion to balance out the charge. Therefore, the formula is going to be Na2S. What this means is there are 2 sodium ions for each sulfide. So in other words, we have 2 sodiums for each sulfide. And if we look at the total charge, 2 sodiums for each sulfide, if I have 2 sodiums, that's going to be +2, and if I have 1 sulfide, that's going to be -2. And when I add those together, it's going to be 0. So when we look at the ratio of cations to anions, it is always going to be the smallest whole number ratio, such that the total charge of the cation is going to cancel out with the total charge of the anion. So let's look at a systematic way to handle writing the formulas for ionic compounds. First, you want to write down the symbol for the metal cation and its charge. And remember, the charge is always written up here in the upper right-hand corner. So I'm going to go ahead and follow these rules for sodium sulfide. So we write down the formula with its charge. So we just did that. Second, write out the symbol for the nonmetal anion and its charge. Okay? And we do this second because in the formula, the metal always comes first, or the positively charged always comes first. All right, now that we've done that, the charge without the sign becomes the subscript for the other ion. So let's look at what we mean by that. Our charge here is +1. This becomes our subscript for the other atom. Now, we are not changing the signs of the ions when we do this. What we are doing is basically a shorthand notation of finding the least common denominator between 1 and 2. And since we're dealing with relatively small numbers, usually you find the least common denominator by multiplying. And so when we bring this 1 down here, what it means is we're multiplying 1 by -2. My total charge here is -2. And when I bring the 2 down here, it means I'm multiplying the 2 by the +1. So 2 times +1 means a total charge of +2. And so these two cancel out. I sometimes refer to this as the switchy technique. Now, there's one last step that's important to remember. After you do this, you want to reduce the subscripts to the smallest whole number ratio and check that the sum of the charges of the cation cancel out the sum of the anions. So let's look at another example. Okay, so we're going to look at writing the formula between the aluminum cation and the oxide anion. Okay, so let's look at a periodic table and see what the charge of these two are going to be. Let me write down the formula first, or the symbol first. We'll learn later why this is called oxide, but we know oxide is going to stand for oxygen at this point, if for no other reason than you're taking my word for it. And here's the symbol for aluminum. So let's look at the periodic table and see what our charges should be. Here's aluminum. It's a metal, so it has to be a positive charge. And it's 1, 2, 3. So its charge is +3. And here's oxygen. It's a nonmetal, so its charge is going to be negative. And it's 2 columns away from the noble gases, so its charge is -2. So let's write our charges here. -2 and 3. Okay, next we're going to switch. And remember, I am not changing the charge. I'm just using this as a shorthand method to find the least common denominator. 2 times 3 is 6, and 3 times 2 is 6. That's what I'm doing. So let's look at the formula that results. Al2O3. I can't reduce these two numbers down any further. They have no common factor except for 1. And let's check. 2 aluminums means okay, so 2 aluminum cations for a total of +6 and 3 oxides. Each oxide has a -2, so if I have 3 of them, -6. The total charge from my aluminum, from my 2 aluminums, and the total charge from my 3 oxides equals 0, which is exactly what I want. Now let's look at a situation where we may have to reduce. Whoops, let me rewrite this. Here's a cation with a +4 charge, and here's oxide. I'm going to do my switch. When I do, my subscripts are 2 and 4. However, these are reducible. 2 and 4 have a common factor of 2. So I'm going to divide each one by 2. 2 divided by 2 is 1. And 4 divided by 2 is 2. This is the correct answer. When we are writing our ratios of cations to anions, it's very important that this ratio is always in the smallest whole number ratio possible. Usually it just works out that way, but once in a while you'll come up with subscripts that you have to reduce down. And this is only true for ionic compounds, so metal and nonmetal. So pause the slide, use your periodic table, and write out the formulas for the 3 ionic compounds made up of the ions listed here. So the first thing I do is write down the symbols: potassium, nitride, calcium, bromide, aluminum, sulfide. Then I look at the periodic table to see what my charges are. Here's potassium, the first column. It's a metal, so its charge is going to be +1. Here's nitrogen, 3 columns away from the noble gases. It's a nonmetal, so its charge is going to be negative. -3. 3 columns away from the noble gases. Let's look at calcium. Here's calcium, an alkaline earth, 2 columns from the left, so its charge is +2. And bromide is a halogen, 1 away from the noble gases, so its charge is -1. Aluminum, 1, 2, 3, is +3, and sulfide is in the oxygen family, 2 away from the noble gases. It's a nonmetal, so its charge is going to be -2. Then I do my switch. Now remember, if there's a 1, we don't put anything there. And if I look at these numbers, I have no reducing to do. Now let's check to make sure the charges really cancel out. If I have 3 potassiums and 1 nitride, I have a total of -3 for my nitride and a total of +3 for my potassium. These cancel out. Here's my calcium. That's +2, and I have 2 bromides. My total charge from 1 calcium ion is +2. My total charge from 2 bromides is -2. These cancel out. Then let's look at aluminum. I have 2 aluminums. Each aluminum has a +3. That's a total of +6. I have 3 sulfides to give me a total of -6.